Hello everyone, my friends, my viewers at home. My name is Adrenaline, the Bazooka Prophet, and today we'll be working on a very important reaction in organic chemistry, which is called a pinacol-pinacolone rearrangement. Now, this reaction is very, very important in the sense that it will open us to a very important area in organic chemistry that has to do with rearrangement. Now, what's rearrangement? Rearrangement can be defined as a reaction in which the carbon skeleton is rearranged in order to give a structural isomer. Now, before that, what we call a pinacol-pinacolone rearrangement. Now, if you look at the word pinacol, it means that it involves an alcohol. And the word pinacolone, look at it. That's one basic thing that you should take note of. Look at it. The pinacol and the pinacolone means an alcohol and a ketone are involved. Now, what's a pinacol? Now, a pinacol are what now? Are completely substituted what 1,2-diols, such as 2,3-dimethyl butane diol. Now don't forget that 1,2-diol or 2,3-diol they all fall under a family of diols which we call the vicinal diol, in which the hydroxy group are adjacent to the carbon, unlike the geminal diol in which the two hydroxy group are located on only one carbon atom. So that's the difference between a geminal diol and a vicinal diol, vicine. Now, so we have said that a pinacols are completely substituted what 1,2-diols. And a very good example that we'll be taking note of here is the 2,3-dimethyl butane diol. And we have said that a pinacol-pinacolone rearrangement simply involve the dehydration. Look at the two statements here, or there are two things here that are worthy of note, and they are dehydration and rearrangement in acid to form what? Ketone. Meaning a pinacol-pinacolone rearrangement involve the dehydration and rearrangement of what now? Of a pinacols in an acid condition in order to form a ketone, and that ketone is called the pinacolone. You can see the reaction right on the board. Now we move straight away to the mechanism. Now in the mechanism, we have four mechanisms under which this reaction can be settled or can be undergone. And the first one is what we call the protonation of the 1,2-diol. Number two, the formation of carbonyl ion by loss of water from the protonated diol. Then number three, rearrangement of carbonyl ion by 1,2 shift, which is where the rearrangement comes in to give a protonated ketone. And number four, the formation of ketone by loss of proton from the protonated ketone. Now we'll be taking each of this mechanism one after the other. Is that understood? So we'll move to the first one, which involves the protonation of the 1,2-diol. And our case study here is the use of the 2,3-dimethyl 2,3 what now? Butane diol. Now we'll move straight away to H3. This reaction is very, very simple. Please take note of how the reaction mechanism should be. Now, see, this is what we call the pinacol. Now, so that in the presence of the acidic medium that will donate a proton, what will happen? Remember, the first step, protonation of the water 1,2-diol. This one, no share. See, how the arrows, look at the way the arrows are drawn. Now, what are we going to have here? We're having, okay, as is very easy. Just follow the way the steps are. Okay, now this is what, if this one should come this way, so you'll be having OH2 plus. So this is what we call what now? The protonated what? Diol. The protonated what? Diol. Now we move straight way to the number 2, which is what now? The formation of carbonium ion by loss of water from the protonated what? Diol. Very simple. So if I'm having something of this nature, which is H3, please follow the way the scheme is, and this is OH, and this is OH. Now I'm having these other cases as OH2 plus. Now, what are we going to have it now? Please follow me. It says formation of the carbonium ion by loss of water from the protonated diol. So what will happen now? This is what will be. So I will be having as H3, okay, that is OH. Oh, this was a little okay. Now we move straight away down here. So that in this case, here become OH, then here becomes, if this water, since this OH2 has been removed, I will now be having what we call the carbonium ion. So this is what we call what now? The carbonium what? The carbonium what? Ion. They will move straight way to the number 3, which is the rearrangement of the carbonium ion by 1,2 shift to give a protonated ketone. So how do we go about it? Simple. This carbonium ion that I have here, we undergo a 1,2 what now? A 1,2 shift. So I'm having something of this nature. Just follow the way I am doing it. It is not difficult at all. So here, this is the OH, remember, and here the carbonium ion. Now, these are the arrow is. There will be a shift, a 1,2, a 1,2 shift. So it means this one comes here. Look at the arrow. Why? Remember, this one will fall back. This one will fall back here. And if that is done, I should be having 1, 2, 3, 4. Then here. And please, okay. So what do we do? Now, till this one has come down here, so I'll be having CH3 here. CH3, that is where the shifting comes in. Then here, we now form a double bond to this oxygen here, the plus, the H and the plus. Remember, this is what we call the carbonium ion, and this is what we call the protonated ketone. The protonated what? Ketone. Now, this protonated ketone here, we now undergo the last phase. The last phase here, let me make it elaborate. Okay, this is the CH3. This is the CH3. Now, this is what we call the protonated what? Ketone. There will be what now? There will be a loss of this proton to give me the last aspect, which is called the pinacol products. So this is what we call the pinacol, starting from the pinacol straight down to the pinacolon. And that is what we call this rearrangement. It's called the pinacol-pinacolone rearrangement. Starting from the first step, formation of the 1,2 diol, in which this acid there, which is a proton coming from the acid there, react with this. So there was, to give us what we call a protonated diol, as you can see here. Now, number 2, which is formation of the carbonium ion by the loss of water from the where now? From the protonated diol. So what will happen? There will be a removal of water to now make this carbon here to be what now? A carbonium ion. Fall back to number 3, rearrangement of the carbonium ion by the 1,2 shift to give a protonated ketone. This is what you see the way the arrow. There was not a shift from the 1,2. So here comes here to give us a protonated ketone. Last one, formation of the ketone by loss of proton from the protonated ketone to give me the pinacolone. Now at this very point now, please, if you have not subscribed to my YouTube channel, do well to subscribe. For now, God bless you.